Alrighty, guys. So 5.2, we're in a new section, 5.2a. This really should be a review of prior grades, like hopefully sixth grade or fifth grade. Okay. All right. So let's look at this first example here. Equivalent ratios are considered proportional. So this is key to understand, and we're going to kind of develop that statement here. Okay. Example, in period 1, the ratio of students wearing shorts to the students wearing pants is 1:3. So you can see that period 1, we've got 4 boxes total. 1 has shorts, 3 boxes have pants. In period 2, the ratio of students wearing shorts to students wearing pants is 4:12. Is this relationship proportional? So notice that we can still draw 4 boxes, but instead of having 1 in each box, we now have 4 in each box, so that we've got 4 shorts and 12 pants. But we can still see the 1:3 relationship in both. Okay. All right, it says, notice how each ratio can be depicted using the same number of parts for shorts and for pants for each class. This means that the two ratios are proportional. Okay, so this is a proportional relationship. All right, number 1, draw bar models to determine if the two ratios are proportional. In 1 box of cookies, the ratio of chocolate chip cookies to oatmeal cookies is 3:8. So is that okay? We've got 11 boxes. Got 11 boxes. This isn't going to be pretty, I don't think. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not bad. A little big on the end, but not bad. All right, so I'm going to use a C for chocolate chip. We've got 3 chocolate chips, and we've got 8 oatmeal. Okay, so the bigger box of cookies has a ratio of 12:32. Okay, so basically, can we draw these same 11 boxes and have a different amount? Remember, each box has to be equal. Okay, so we've got 1 of each type of cookie in each of these boxes. Okay, if we have 12 chocolate chip, wouldn't we have 4, 4, and 4? So that's 12, and look at that, matches this up here. That's all chocolate chip right here. Okay, now let's look at the oatmeal and make sure we're good with the oatmeal. 32. If I have 4 O's in all these boxes, would I have 32 altogether? 2, 3, 4. 2, 3, 4. 2, 2, 3, 4. 2, 3, 4. 2, 3, 4. 2, 3, 4. 2, 3, 4. Yep, it does. Okay, so think about this right here. That's kind of the line. So you should be able to see that 12:32 is the same relationship as 3:8. Okay, so yes, these are proportional. The ratio of cats to total pets in the first pet store is 3:9. In the second pet store, the ratio of cats to total pets is 6:18. All right, so be very careful. This is cats to total pets. So cats are a part of it. Okay, so we've got 9 boxes. Okay, that doesn't look very even, but I've got 9 boxes. Okay, and all of these are total pets. And 3 of them are cats. Okay, now we need to see if the second store, if we can set up 6 and 18 in the same fashion. Okay, I'm going to copy my very not a very good spread out boxes here on that next one. I tried to copy what I had up there so we can look and see if they're the same or not. All right, is there a way to put a number of cats in this box, and this box, and this box to get 6? That would need to be, all right, so I've covered my cats. Now let's think about that. If I've got 2, 2, 2, 2, 2, 2 of some other animal, does that get me my 18 total? Yes, it does. Okay, so I've got to think about kind of that line right there. Okay, so yes, this is proportional. Yes, these are proportional. All right. Now the information in both 1A and 1B has been transferred to the tables below. Okay, so take a look at this. I've got my chocolate chip cookies and oatmeal cookies, 3 to 8 and 12 to 32, and then I've got my cats. Got my cats, 3 to 9 and 6 to 18. I'm not sorry, cats to total pets. All right, so it says, how do the tables help you determine if the ratios are proportional? So we're not going to be drawing these models, especially when the numbers get bigger. Like this was kind of a pain. Okay, so is there a way we can use these tables to help us come up with a yes, these are proportional, or no, these aren't proportional? Okay, so I want you to think about, let's look at this one first. Let's look at this one first. I think it's easier to see. Okay, is there a number we can multiply to the 3 and the 6 to get 9 and 18? Okay, and hopefully you're thinking that's a 3 and that's a 3. Okay, well, if this number is the same, guess what? The relationship is proportional. Okay, let's look at this one. This is harder because it's not a nice even whole number. Okay, so 3 times something is 8/3. I'm sorry, is 8, and I just gave away the answer. Okay, what if I multiplied by 8/3? Think about that over here. 3 over 1 times 8 over 3. Don't those 3's cross cancel and you're just left with this 8? Let's see if that works here too. Is it true that 12 times 8/3? Let's look at that. 12 over 1 times 8/3. Can you see that the 3 and the 12 would cross and leave a 1 and a 4, which gets us 32? Okay, so since, let me circle those so I can refer to them here. So since the circled numbers in each table are the same throughout the table, the relationship is proportional. All righty. All right, let's look at the next page. All right, the ratio of pink flowers to purple flowers in a vase is 6 to 8. The ratio of pink flowers to purple flowers in a different vase is 8 to 10. Draw bar models to determine if the two ratios are proportional. Okay, so I'm going to draw, I'm seeing like a common number here is 2. Okay, so could I put 7 boxes? Let's look at that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so if I have 6 pink, 2 pink, 2 pink, 2 pink, and then 8 purple, 2 perp, 2 perp, 2 perp. Uh-oh, I got too many here. 2, 4, 6 pink. I should have did that in pink. I'm good. 2 perp and 2 perp. Perp. All right, that's the first vase. Okay, this is vase number 1. Okay, now vase number 2. Number 2, I need to draw the same exact setup and think about, is there a way to set up 8 pink and 10 purple? No, there's no way to do 8 pink and 10 purple. I'd have to have 9 boxes. There's no way I can fit that in 7 boxes. Okay, so if I put on 2 more boxes, now we're completely off, right? This is not proportional. This is not proportional. Okay, if I tried to squeeze 9 boxes into this space here, my pinks would not land in the same exact pink spot as this one up here. Okay. All right, now let's look at this relationship in a table, just like we did on the last couple of examples. So 6 pink flowers to 8 purple flowers, 8 pink flowers to 10 purple flowers. Okay, let's come up with the number that we would need to multiply pink by to get purple. Okay, so we're going to just do this number over this number. Okay, so 8, 6 is 4/3. Now think about that. If I multiply 6 over 1 times 4 over 3, I get 8. Okay, now this one, 10 over 8, ooh, 5/4. Let's see if that, make sure that gets us. If I multiply 8 over 1 times 5 over 4, that would be 10. Okay, these pink numbers right here are not the same. Okay, so since the circled numbers are not the same, this relationship is not proportional. Okay, so going back to the examples that we had, okay, this was the cookie example right here. This was the pet example, and this is the flower example. Okay, they want you to simplify the ratios. So 3/8 is already simplified. 3/8. 12 over 32, 4 goes into both of those. 4 goes into both of those 3/8. Notice how these are the same? They were proportional. 3/9 would simplify to 1/3. 6/18 also simplifies to 1/3. They are proportional. This guy, 6/8 would be 3/4. This guy would be 4/5. Nope, they're not proportional. Okay, so let me write this in pink so it doesn't blend in with this answer up here. Is proportional. These were is proportional. And this was is not proportional. All right, okie doke. Last page. Determine which of the 4 tables below has relationships that are proportional and justify why or why not in words. For each table that is proportional, find the constant that multiplies x to get y. Okay, let's think about, that would be a 2. Oh, okay, so these are all 2s. Okay, so yes, this is proportional. Yes, to get the y value, the x is multiplied by 2. The constant then is 2. Okay, let's look at this guy. What multiplies 2 to get 1? 1/2. 1/2, 1/2, 1/2, and 1/2. Yes. Yes, this is proportional. To get the y value, the x is multiplied by 1/2. The constant is 1/2. All right, this one. Whoops, times 2. My brain was already thinking about the next row. Times 3, times 10/3, times, we already know it's no. Okay, times 14/4 or 7/2. No, this is not proportional because the pink number is different on every box, every row. No, there is no value that is constant that multiplies x to get the y values. All right, this guy. If I multiply this by 3, yep, 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 yep. So yes, this is proportional. Yes, to get the y value, the x is multiplied by 3. Therefore, the constant is 3. All right, if the relationship above is proportional, write an equation that relates y to x in the form of, you're going to write y equals something. Okay, so if it's proportional, this one we're not doing, it's not proportional. Okay. Oh, it says if not, right? Not proportional. Not proportional. Okay, but this one is. This one is, and this one is. All right, so we're always going to be in the form y equals something times x. Okay, what number should go in here, do you think, for this box? The pink number, 2. So this says you get the y's if you multiply the x's by 2. That's what that says. Okay, what number are we going to put in this one? 1/2. This says to get our y values, you multiply x by 1/2. This one wasn't proportional, so we can't give an equation. This one, what number? The pink number is 3. To get our y values, you multiply all the x's by 3. All right, let's look at this last question here. It says determine if each set of ratios below is proportional by writing them in simplest form. All righty, so 7/9 is already in simplest form. 3 can go into both of these, 7/9, so yes, this is proportional. 10/12, 2 goes into that. 5/6, 15/30. 15 goes into both of those. No, these are not proportional. 1/3 is already simplified, and so is 3/16. Nope, not proportional. 5 goes into both of these. 3 times, 7 times. What goes into 24? 4 goes into both of those. That 52 is kind of a sneaker one. 6/13. Nope, these are not the same. 9/12. 3 goes into that 3/4. 49/50, no, that stays, so this is a no. Okay, this is a 7/10 that stays. 28/40, 4 goes into both of those. 7/10, this is a yes. Okay, can you think of other ways to determine proportionality? I can. Okay, one way that we didn't do it here is if you have a calculator, you can divide the numbers. Sometimes that gets decimals. Sometimes getting decimals. And compare them. Oopsie, sorry. Okay, if you have a calculator, okay, couldn't I put in 7 divided by 9 and see what that answer is, and put 21 divided by 7 and see what that answer is? And if they're the same, yes. That's another way to do these. All right, so that ends our discussion on 5.2a. Thanks, guys.